Hello everyone. Today we have a quadratic problem we want to solve. So the question says find the values of the real parameter p such that the quadratic equation p minus 1 x squared minus 2px plus p plus 3 is equal to 0 has two distinct positive roots. So let's start solving this problem. Okay, so we know that a quadratic equation has two distinct positive roots if its delta or its discriminant is positive. So let's write it first. So if delta or discriminant is greater than 0, then the quadratic equation has two distinct positive roots. Sorry, two distinct roots, not necessarily positive. If the discriminant is 0, the quadratic equation has a repeated root, and if the discriminant is negative, then the quadratic equation has no real root. Here we are interested in the case when we have two distinct roots, basically when the discriminant is greater than 0. So we are gonna find the discriminant of this equation. I'm gonna rewrite this equation. So p minus 1 x squared minus 2px plus p plus 3 is equal to 0. In this equation, the variable is x. So basically x is the variable and p is a constant with unknown value. So basically we want to find the value of p. And yeah, as you know, for the discriminant we call this part a, this part b, and this part c, and the discriminant is b squared minus 4ac, so it's gonna be minus 2p squared minus 4p minus 1 and then times p plus 3. We are gonna simplify this. It will be equal to 4p squared minus 4, and then we have p squared plus 3p minus p minus 3, and that would be equal to 4p squared minus 4p squared plus 2p minus 3, and if we simplify that, it would be 4p squared minus 4p squared minus 8p plus 12. So basically the discriminant will be equal to minus 8p plus 12. Let's continue in the next page. So again, this is our quadratic equation. The discriminant is this one, minus 8p plus 12. And now the discriminant should be greater than 0. So minus 8p plus 12 should be greater than 0, which means that 8p has to be less than 12, meaning that p needs to be less than 12 over 8, or p has to be less than 3 over 2. So that is one criteria, p has to be less than 3 over 2, but in addition to what we have, that p has to be, the equation has to have two distinct roots, the roots also have to be positive, so that's another condition that needs to be met. Okay, so if the roots are positive, it means that if we add them, so root 1 plus root 2, that should also be positive. And if we multiply these roots, so root 1 times root 2, if we multiply them, that should also be positive. So that is the result of having two positive roots. Okay, so in a quadratic equation, I'm gonna keep this one here. We are gonna need it in the end. Okay, so in an equation, in a quadratic equation, we know that c is the sum of the two roots. So c, which is p plus 3, is the sum of the two roots. And here we said that the sum of the two roots should be greater than 0. That means that p has to be greater than -3. And we also know that in a quadratic equation, b is this multiplication of the two roots. So minus 2p, here we said that that also has to be positive. It means that this also has to be positive. And that means that p has to be less than 0. Now we have three ranges for p, and we have to see which one is going to become what range is going to be the final range of p. I'm going to list all the three p values on the top of the page. So p has to be greater than -3, p has to be negative, and p has to be less than 3/2. I'm gonna draw a number line, so it starts from -4, -3, -2, -1, 0, 1, 2, 3. So the first one says that p has to be greater than -3. So these are all the values that p can get, right, according to the first inequality. According to the second, p has to be less than 0. In the range shown by green, the only part that is acceptable is this part that I'm gonna show. So among this whole part, the only part that is acceptable, so p has to be less than 0, is gonna be this one. And finally, looking at p is less than 3/2, we see that if p is less than 0, it is automatically less than 3/2 as well. So looking at this number line, we see that the range for which this initial equation that we had has two distinct positive roots is going to be p less than 0 and greater than -3. I hope you enjoyed this solution. If you have any questions or any comments about my solution, I would be more than happy then to help you. Have a great day. Until next time.